Welcome back to another session of Ansys tutorial. In this tutorial I'll be dealing with Ansys multi-body dynamics. So for that, what you need to do is you need to go to Transient, Structural, MBD. Make sure you select MBD, not Ansys MBD, for multi-body dynamics. Click and drag drop. So in today's studies I'll be using a governance system for my for explaining how to formulate your problem. So I'll just right click in my geometry and import geometry. I already have a parasolic form of governor assembly. I'll just click OK and I'll start a mechanical multiphasic system. So, okay, here we go. This is my rough idea of a governor. Well, it doesn't look actually like that, but it's just to explain it. Fine. So in order to check that whether the body is truly MBD, what you need to do is you need to go and check underneath the geometry. Click on each part or a solid. You should see the stiffness behavior should be rigid, not flexible. Okay, so that is another thing. And another thing you will notice is if it's a rigid, it will have a separate coordinate system. The system will have a separate coordinate system. I'll just change it to flexible, and you could see the coordinate system has gone for the governor shaft main. So I'll just change it back to rigid, and you could see it is now it's back. Fine. Okay, so that was about the geometry. And about the coordinate system, there's only one global coordinate system I have. And regarding connection, there will be no contacts between any of the bodies or a body surface because we are in MBD. So I'll just delete all of them, which has been done like self-developed. I'll go to connection, and from here I'll go for body to ground contacts and body to body contacts. Okay, these will establish a normal relationship between each and every body because and they are fixed in their own coordinate system. So these options are very much useful to relate the coordinate systems. So I'll start up, I'll click on fixed. So the center shaft, I'll keep it as fixed for myself. Just in this tutorial I'm considering fixed. In actual case it does not fix, it's a driven. Okay, so I'll say okay, and you could see it's been fixed. So I'll go to body and I'll say revolute. So I'll click on this and I'll say apply, and I'll select to mobile one, and I'll say view body. So in this body I could easily I could use this option in order to simplify my selection process. Okay, so right now I'll click here and I'll select this geometry. It will automatically appear. I'll select the inner one because that is the thing about which it need to be revolved. So I'll say okay. So I'll jump to I'll go back and select another revolute, and select this one as my reference, and this surface again as my mobile, and I'll say apply. Revolute joints I have, say apply, and go select mobile, and I'll say apply. Okay, there's another thing I would like to tell you is over here itself it will tell you the connection type, the type of connection you have, and type, connection type existing between two bodies or effects. You can even put your torsional stiffness and a damping coefficient for the particular object. A rigid body one, it's not a material property you're putting the property for the rigid component, but you could always consider it to, like, you can manipulate it, and it could be always equal to material, not the exact material property, well calculated one. So I'll carry on with my selection. I'll go to revolute and select apply, center selection, apply again, body to revolute. Well, body views always helps you in order to select your components, especially when you have a big assemblies of components and you don't know what you have to do. So they are really helpful. So right now I would just like to check how does my product behave. So I'll just go to the main revolute and I'll say configure. Now a triad will appear with 3 axes, which will give me a freedom of axis, give me a freedom along the 6 degrees of freedom. One is along my x-axis, z-axis and y-axis, and rotation about x-axis, rotation about x-axis, rotation about y-axis, rotation about z-axis. But in this case, the revolute has been activated only about x-axis. So that's the reason the degree of freedom along the y-axis. The degree of freedom along the y-axis is only active. So and it highlights you in a, I would say it's something very light green blue color. I don't know. So I'll just keep my cursor selected and I'll rotate and see. Now you could see how it behaves. Fine. I'll repeat the same thing with another joint. I'll say configure. Over here, my axis of rotation is about z-axis. Fine. And you could see, but I need to fix up the bottom part also, so I'll do it right now. And if you want to set it to a certain degree, you can always set it stating here and click set, or if you want to, for an instant I'll put it as 100 and you could see it has been set to 100. If I'll say set, it will set that itself. If you want to change it, you can always click revert and it will go back to original position where you've been working from. So here I got few warning messages. Nothing to worry at this point of stage. Okay, I'll just fix up. I'll just give a relation for the bottom slide. And I'll just see whether I could set my cylindrical option so that it will help me out in one or other way. Okay, it works out well. Back and see. Well, that works absolutely fine for me. Well, that is absolutely fine for me. So I've done with my connections. So I'll close this tree, jump to transient, analysis. And analysis setting, I'll put number of steps to be 3, and you could see these are the tabular columns. And over here, I'll put a remote displacement rather than putting any kinds of load. So I'll just rotate it with respective by specifying the displacement. I'll select the geometry that I would like to, for which I would like to specify the displacement. So I've selected one. So I need a rotation about y-axis. So I'll just click in here and say tabular time. So for first, I'll put 180. For second, I'll put 360. 180 plus 180 is 360. And for third, I'll put 540. 540. Okay, I'm done, and I could go to graph and I could see the displacement is increasing linearly with respective to the time. Okay, and another thing I'd like to tell you is, if I'll just put it as 180 back, check out the difference in a graph. Okay, so it comes back to 180. So the thing is, here the reference is made with respective to the origin, not with respective to the previous displacement you have specified. So this displacement is always with respective to the 0, not with respective to the previous value you have specified. So I'll keep it as 50. Whereas in few soft I remember working in SolidWorks rigid body dynamics. In there I had a problem, so it was with respective to the previous steps. So it's just a idea I'm giving you. So I'll jump to solution. I'll say total deformation. Well, it won't give me a total deformation anyhow. Let's just select the spring. Okay, I'm not done with the spring, so I'll go back to my connection and body to body spring, and I'll select this phase. I'll say apply, and I'll select this phase. I'll say apply. So my spring is done, and longitudinal surface I'll put 0, 0, 5. Okay, I could even add a damping, but I won't be adding it because you could see the better fluctuation values without a damping. Springs are known for the fluctuations. Fine. So I'll just jump back to solution and I'll go to